Welcome. What you see here is a model that we made of the peritoneal development during the embryological phase. It's a homemade model that we developed to show you how the peritoneum, that's a very complicated configuration, how that configuration arises during the embryological phase. The video about this model will consist of 4 videos that depict 4 different steps. This is the first video. This first video, I'll first introduce you to what you see on this model. Okay, let's have a look. This stands for the back wall of the person. This stands for, of course, for a person, for an embryo actually, so it's quite enlarged. This is the back wall, and this is the front wall, the abdominal wall. Then you see the liver, you see the stomach, and you see the pancreas. And you see this long pink tube, that's the gut. Originally, in the very early embryological phase, the gut was an unflexed tube that protruded in the umbilical cord. Not as much as this, but it does protrude outside of the body because the body grows less fast than the gut tube grows. So the gut tube grows, in fact, outside the body, like it's shown here. And all this plastic that you see stands for the peritoneum. Well, the peritoneum, you must imagine that the peritoneum originally was a balloon that filled actually the whole abdominal cavity. And you see this plastic here on the back wall is in fact the peritoneal layer that's on the back wall. And you must imagine that it's not only here on the back wall, but that the peritoneum as a balloon was completely surrounding here the inside of the abdominal wall. We didn't make it here because then you of course wouldn't see the model. But so you must imagine that this is all peritoneum. Now comes the gut in place. The gut, you must imagine that the gut was a long tube that pressed from the backside of the body into this balloon and then drew with it the peritoneum. And in this way I got this configuration with from the back wall peritoneum, that's called parietal peritoneum. From the back wall I get peritoneum layer going all the way to the intestine and then going all the way back and again ending in the back wall. So in fact the gut tube drew with it a double layer of peritoneum. Also you see that the gut drew with it blood vessels. And that's because behind the peritoneum are the large blood vessels. You see here this blue is the inferior vena cava and the red is the aorta. And here you see the kidney. These structures, as you see, are behind this plastic. In fact, they are behind the peritoneal cavity, so they're called retroperitoneal. And the only way that blood vessels can reach the gut tube is through this double layer of peritoneum. And such a double layer of peritoneum is called a mesentery. A mesentery is, by definition, a double layer of peritoneum that arose through invagination of the gut, that connects the gut with the body wall, and that gives pathway for the blood vessels and nerves and lymph vessels from the body wall to the gut. Now we in fact have two mesenteries, and this large mesentery is at the back of the gut tube, and it's all the way up from here, from the stomach, all the way down here, all the way to the upper part of the rectum, and it's at the back of the gut tube. It's called the dorsal mesentery. There's also, and you see that around here, and then maybe I have to rotate the model slightly a bit. There's some mesentery over here to the front of the gut tube. That's called ventral mesentery. But that mesentery is in fact only at the location of the liver and the stomach. So below that there's no ventral mesentery. And this ventral mesentery in fact consists of two parts, a part in front of the liver and the part behind the liver, between the liver and the stomach. Originally it was one ventral mesentery, and the liver grew out in that ventral mesentery and then divided it in these two parts. These two parts both have a membranous part and a thicker lower border. You see here a membranous part and a thicker lower border. Okay, the part at the front of the liver that runs from the front abdominal wall to the liver, this membranous part is called the falciform ligament. And at its lower border is the umbilical vein. You must imagine that the navel or the umbilicus was here with the umbilical cord connected to it here. And this umbilical vein was the blood vessel that transported all the oxygenated blood that the embryo got from its mother. So the falciform ligament and the umbilical vein, and later on in adults this becomes the round ligament of the liver. Then we move over to the back of the liver, and we get the part of the ventral mesentery between the liver and the stomach. And that's called the lesser omentum. And the lesser omentum consists of, again, a thick border and a thin membranous part. The thick border is called the hepatoduodenal ligament. That comes from hepar, which is liver, and it runs to the duodenum. And the thin part is called the hepatogastric ligament because it runs from the liver, hepar, to the stomach, which is called gaster. So hepatogastric and hepatoduodenal ligament. And in the hepatoduodenal ligament you see three colors standing for three tubes. There are red, blue and green. In that hepatoduodenal ligament is the bile duct, is the portal vein, the blue one, and the red one stands for the hepatic artery. The green one is the bile duct, the blue one is the portal vein, and the red one is the hepatic artery. Okay, this was an introduction of the model. To recap, we have a gut tube with a dorsal mesentery completely from top to bottom, and the ventral mesentery consisting of two parts, falciform ligament in front of the liver and the lesser omentum between the liver and the stomach, both consisting of a thick part and a membranous part, here called the falciform ligament and the umbilical vein. And here we have the hepatoduodenal ligament and the hepatogastric ligament. So far the introduction of what you see in this model.